Chapter 1, Section 2, Finding Linear Equations and Functions. That should be plural. Let me change that for us. All right, cool. And functions. Let's get started. In this first example, it says find the slope-intercept form of or for the equation of the line with slope -2 and y-intercept 0, 5. What I want you to notice is that slope-intercept form is y equals mx plus b. So in order for you to write any equation in slope-intercept form, you need two things. You need the slope, which is m, and you need the y-intercept, which is what b is. But notice that in this problem, they gave you the slope, so you know m is -2, and they gave you the y-intercept, so you know that b is 5. So then, because they gave you exactly what you needed, all you need to do is plug those things in, and you're done. It's that simple. This is the slope-intercept form for that equation. Obviously, they're not going to give you everything you need, the slope and the y-intercept every single time. But when they do give you the slope and the y-intercept, it's pretty simple. Let's go to the next example. Find the slope for the equation of the line that's going through 0, 1, and 2, 5. Okay, notice they're asking you for the slope of a line, and they gave you 2 points. What you're going to need in this example is something called the slope formula, and I'm going to give it to you now. So the slope formula is m is equal to y sub 2 minus y sub 1, that's a y there, let me make it look more like a y there, over x sub 2 minus x sub 1. I think it would be a good idea if you wrote this down in your notes and you highlighted it, label it as the slope formula. You're going to need to use this formula many times throughout this course. Now, these subscripts here, 2 and 1, and these subscripts here, they're just used to differentiate between one x coordinate from another, one y coordinate from another. So what a lot of people like to do, and you're free to do this as well, is 0, 1 here can be considered x sub 1 and y sub 1, whereas 2, 5 can be considered x sub 2 and y sub 2, so that when you actually apply the formula for this problem, it'll be y sub 2 minus y sub 1, which is 5 minus 1, over x sub 2 minus x sub 1, which would be 2 minus 0. Doing the arithmetic, you would find the slope of this line to be 2. That's your answer. The slope is 2. Remember, the slope describes the steepness of the line. This slope happens to be positive. So if you were to graph this line, you would find that the line is going up from left to right. Now, we found the slope by doing y sub 2 minus y sub 1. We did 5 minus 1, and then we did x sub 2 minus x sub 1. We did 2 minus 0. The really cool thing is that you get the same slope even if you change the order of these coordinates. So if you do y sub 1 minus y sub 2, and then x sub 1 minus x sub 2, you get the same slope. Allow me to illustrate that now. So with this variation of the formula, we're going to get that m is, 1 minus 5 over 0 minus 2. And the reason why I'm doing the arithmetic as I'm talking, the reason why the slope will come out the same is because the ratio is the same. Okay, so it doesn't really matter whether you write it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or if you do y sub 1 minus y sub 2 over x sub 1 minus x sub 2. The main idea here is that you find the difference between your y coordinates, the difference between your x coordinates. For this next example, they're asking us for the slope again, and they're asking us to find the slope of the line that's going through -2, 4, and 0, 1. So I'm going to go ahead and use my formula, the slope formula. I'm going to consider this to be x sub 1 and then y sub 1, and then I'll consider this to be x sub 2. Okay, that's really sloppy. Let me go back there. I'll consider this to be x sub 2 and y sub 2, all right? So then when I do, I'll just stick to the traditional way. I think most people remember the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But again, you can change the order if you'd like. But if you did it this way, it'd be 1 minus 4 over 0 minus negative 2. Now be very cautious about your signs here. 1 minus 4 is negative 3, and 0 minus negative 2 is just 0 plus 2. So then the slope is negative 3 over positive 2. Notice that I put the negative sign in front of the slope, in front of the fraction, as opposed to on 3. That's just a preference of mine. So the slope is negative. If you were to graph this line, if you were to look at a picture of this line would be going down from left to right. Find the slope for the line passing through these 2 points. Let's use the slope formula again. I'm going to kind of stick to my pattern here, calling the first set of coordinates x sub 1, y sub 1, the second set of coordinates x sub 2 and y sub 2. Okay, but feel free to change that if you want for yourself. So then the slope formula will give me 4 minus 4 over negative 1 minus 3. 4 minus 4 is 0, and then this denominator is negative 4. 0 divided by negative 4 is just 0. So then the slope of this line is 0. Wait a minute. What kind of lines have 0 slope? Horizontal lines, that's right. So this must be a horizontal line because all horizontal lines have a slope of 0. Make sure you have that in your notes. All right, very good. Let's keep going. Find the slope for this line that's going through these points. Let's do this again. I invite you to pause this video and to do this problem for yourself. Go ahead and pause it now. All right, I hope this is what you got after finding the slope. It is undefined because you can never divide by 0. So then what kind of line is this? You're right, it's a vertical line. All vertical lines have undefined slope. All right, very good. I hope you're learning. I hope this is making sense for you. Let's continue. We now shift our attention to point-slope form of a line. We're going to start with the slope formula so that I can show you where the point-slope form of a line comes from, so it's not coming out of left field. All right, this is the slope formula. The slope formula can be rewritten with only one set of subscripts. So if I just write it as y minus y sub 1 over x minus x sub 1, you can rewrite it with only one set of subscripts. And then what you may want to do is clear the fractions. You can clear the fraction if you multiply both sides by the denominator. That is to say, multiply both sides by x minus x sub 1. I'll show you how I do that here. X minus x sub 1. Over here as well, x minus, ooh, can I fit it? Barely. All right, that would cancel out this denominator and that expression there. And then what that will lead you to, if I can kind of come over here, okay, then I'm going to write down the right-hand side first. You would have y minus y sub 1, which would be equal to m times x minus x sub 1, okay? This here, ladies and gentlemen, is called point-slope form of a line. You would use this little formula, if you will, whenever you are asked to find the equation of a line and you've been given the slope and a point. So we have the point-slope form of a line, y minus y sub 1 is equal to m times x minus x sub 1. Okay, so let's see if we can find some equations for linear equations for some lines using the point-slope form. Now keep in mind, we use this to find the equation of a line. All we need is the slope and a point. Now the point that they give you, you're going to substitute it in for x sub 1 and y sub 1. You're not going to substitute anything in for x or for y most of the time. You're going to be substituting the point that's given to you for x sub 1 and y sub 1. All right, let's go. Check this out. Find the slope-intercept form for the equation of the line with slope 4. Hey, let's highlight that. This is your m value. And through 2 comma negative 1. I'm going to consider this to be x sub 1 and y sub 1. All right, let's go. So here's point slope form of a line. I'm going to plug in what they gave me. Y minus negative 1 is equal to 4 times x minus 2. I plugged it in. Now, all I have to do to finish this is to solve for y. Because remember, slope-intercept form is y equals mx plus b. That is to say, y is isolated. So all we have to do is isolate y. I'm going to go ahead and distribute the 4. And then I'm going to subtract 1 from both sides. Subtracting 1 from negative 8 gives me negative 9. So there I have it. I have the slope-intercept form for the line whose slope is 4 and that goes through the point 2, negative 1. Now, find the slope-intercept form for the line that's passing through 2, 5, and 0, 1. Now, we're going to want to use the point-slope form of a line, but before we use that little formula, remember what we needed? We needed the slope. And they didn't give us the slope. Well, not explicitly, they didn't. So before we do anything, let's go find the slope. The slope for this line would be equal to 1 minus 5 over 0 minus 2. What I just did there is this y value minus that y value over this x value minus that x value. So this would give you negative 4 over negative 2, which is positive 2. Now that I know the slope, what I can do is go to point slope form. There it is. And plug in what they gave me. Now remember what you're going to do. You're going to substitute in not just your slope, but you're going to plug in a point for x sub 1 and y sub 1. But wait a minute. Which one of these points? Good news, it doesn't matter. Choose whichever one of these points and plug them in for x sub 1, y sub 1. So if you don't mind, I'm going to go ahead and choose this point, okay? And I'm going to use 0 as x sub 1 and 1 as y sub 1. So going back to here, y sub 1 would be 1 is equal to 2 times x minus 0. The good news is you're going to get the same answer regardless of which of these ordered pairs that you choose. So you get y minus 1 is equal to 2 times x, right? So add 1 to the right and you have your final answer. Adding 1 to 2x just gives you 2x plus 1. This is slope-intercept form for this line. Isn't that great? Now check out this example. Find the slope-intercept form for the line that's going through 2, negative 3 and parallel to the line y equals 4x plus 1. Now, the key word here is parallel. When you have a line, a pair of lines that are parallel, that means their slopes are the same. So then what that tells me then is that if my line is parallel to this line, that must mean our slopes are the same. Well, the slope of this line is 4, right? Because this is mx plus b form. So if this guy's slope is 4, my slope is 4, right? This arrow here implies that my slope is 4, the same as that guy's slope. All right, now that I have the slope and a point, I can use the point-slope form of a line to find my equation. So y minus y sub 1 is equal to m times x minus x sub 1. I'll go ahead and plug in the y coordinate that they gave me. It's right there. Negative 3 is the y coordinate. So be careful with your signs there. Plug in your slope. Plug in the x coordinate that they gave you, which is 2. 2 is right there. So now just simplify and solve for y. Distribute the 4. Subtract 3 from both sides. When you subtract 3 from both sides, you get negative 11. All right, so then this is the slope-intercept form for the line that is described above. Now check this out. Find the slope-intercept form for the line that's going through negative 1, negative 5, and parallel to the line 2x minus 4y is equal to 3. Now, the fact that our line is parallel, right, oops, sorry, parallel to this line, 2x minus 4y is equal to 3, means that our slopes are the same. The problem here is I can't see what this guy's slope is because it's not written in slope-intercept form. So what I'm going to do first is I'm going to take this equation, write it in slope-intercept form, which means y equals mx plus b form. I'm going to solve for y. I'm going to be able to see then what its slope is, and my slope will be the same as that. I hope that strategy makes sense. So here we go. 2x minus 4y is 3. Let's solve for y. I'm going to subtract 2x from both sides. When I subtract 2x from both sides, this is what I have. Now I'm going to divide everybody by negative 4. So then the slope-intercept form for the line that they gave me in the problem is positive 1/2 x minus 3/4. Now, the important part of this is that the slope of this guy is 1/2. That means my slope is also 1/2, right? Because our lines are parallel. If our lines are parallel, then our slopes are the same. All right, great. Now, I have my slope and I have a point that my line goes through. I'm going to take this point and this slope and plug in this information into point slope form to find the equation of my line. All right, everybody. So y minus, now my y coordinate is right here, negative 5. Be careful with your signs. We've just found the slope to be 1/2, so I plug that in. X minus, now x sub 1 is right here, negative 1. Again, be careful with your signs. There. So all I have to do now is solve for y to get the slope-intercept form. Before you distribute the 1/2, can you please write this as x plus 1 to simplify that a little bit? Don't subtract 5 from both sides yet. You should distribute the 1/2. There we have it. So what we're going to do is, well, I'm going to move the screen up a little bit. What I'm going to do is I'm going to subtract 5 from both sides. So I'll have 1/2 x plus 1/2 minus 5. I have to do some arithmetic for these fractions here. 1/2 x plus 1/2 minus 10/2. Now, let me take a little commercial break here and make sure you understand where I got 10/2 from, all right? I have the number 5. It's right here, right? What I want to do is subtract 5 from 1/2. You and I know that you cannot add or subtract fractions unless they have the same denominator. This fraction has a denominator of 2. Therefore, I want to write negative 5 as a fraction whose denominator is 2 so that they have the same denominators, and then I can add or subtract them. So watch this. The number 5 is the same thing as 5 over 1. And I want this fraction to be a fraction whose denominator is 2. Well, then I have to think to myself, what would I multiply 1 by in order to get 2? You have to multiply 1 by 2 to get 2. What if you multiply the bottom by 2, you're going to have to multiply the numerator by 2 as well. 5 times 2 is 10. That's how I made 5 be 10 over 2. All right, now I can continue with my arithmetic. So y is equal to 1/2 x, and then this is minus 9 over 2. All you got to do is subtract 10 from 1, which is negative 9, and keep the common denominator. This is slope-intercept form for this line. Pretty fun. Check this out. Example 10. Find the slope-intercept form for the line through 2, negative 3, and perpendicular to the line y equal to 4x plus 1. Now, do you remember perpendicular lines? Their slopes are opposite reciprocals. So if my line is perpendicular to this line, well, that means my slope is going to be the opposite reciprocal of this guy's slope. This guy's slope is 4. Therefore, my slope will be the opposite reciprocal of 4. All right, so the opposite reciprocal of 4 means opposite in sign, so it's going to be negative, right? If 4 is positive, that means if this guy's slope is positive, that means my slope will be negative. That's the opposite part. Reciprocal means flip the number upside down. Now, the number 4 is the same thing as 4 over 1. So when you flip it, when you reciprocate it, it becomes 1 over 4, right? So this is our slope, negative 1 over 4. That was all from using the word perpendicular. Now, I have my slope and I have a point, so I'm going to go ahead and go to point slope form to find the slope-intercept form of my line. All right? All right, here's point slope form. I plugged in the slope that we found, and I plugged in my coordinates of positive 2 and negative 3 right there. All we have to do now is solve for or isolate y. Move this up for us. All right, so let's do it, guys. So then this becomes y plus 3. Distributing negative 1/4 becomes negative 1/4 x plus, because a negative times a negative is a positive, I have 1/4 times 2. I'll do this on the side here. When you take 1/4 and you multiply it by 2, I cross cancel. So 2 goes into 4 twice. So then this really just becomes 1 over 2. Okay? Don't forget that 2 is really 2 over 1, right? So it's 1 over 2. So when I come here, it'll be positive 1/2. All right, I'm going to subtract 3 from both sides. I'm going to subtract 3 from both sides, like that. Now I have to do some fraction work again, right? I need 3, or negative 3, to be rewritten as a fraction whose denominator is 2. Allow me to write it down here. The number 3 is really 3 over 1, and I want this fraction to have a denominator of 2 so that it can match the other fraction. If you multiply 1 by 2, you'll get 2 down there, but then you have to multiply the numerator by 2, so there it is. 3 is really 6 over 2. So let me go back to our problem here, and I'll say y is equal to negative 1/4 x plus 1/2 minus 6 over 2. Okay? Which will then lead us to negative 1/4 x minus 5 halves. This is the slope-intercept form for this equation. Pretty cool, guys. Good work. Example 11, find the slope-intercept form for the line through negative 1, negative 5, and perpendicular to the line 2x minus 4y is 3. Let's do this problem exactly the same way. I mean, if my line is perpendicular to this line, that must mean my slope is the opposite reciprocal of this guy's slope. Oh, you know what? There is a slight problem. I cannot see what this guy's slope is because it's not written in slope-intercept form. So let's go ahead and rewrite this equation in slope-intercept form. I'll then be able to see what this guy's slope is, and then I'll figure out what my slope is, which will be the opposite reciprocal of this guy's slope. All right, what I would love for you to do is to pause the video, and can you take the time to write this in slope-intercept form, identify what this guy's slope is, and then use that information to find your slope. Okay, I hope this is what you found. I solved for y here, and I found that this guy has a slope of positive 1 over 2. Positive 1 over 2. Therefore, because our lines are perpendicular, my slope will be negative 2 over 1, or just negative 2. I hope you agree with me. So now that we know our slope and a point, let's go to point slope form and find the equation for our line. All right, I'm going to plug in my y coordinate of negative 5. We found the slope to be negative 2 and the x coordinate of negative 1. Remember, my x and y coordinates are coming from that point there. All right, so I'll simplify this. This is y plus 5 is equal to negative 2 times x plus 1. Y plus 5, I'll distribute the negative 2. and I'll subtract 5 from both sides. And I have it. This is slope-intercept form for our line. Awesome. All right, find the equation for the horizontal line through -3, 1. All right, do you remember from a previous lesson that all horizontal lines, first of all, have slope 0, and their equations look a certain way? All of the equations for horizontal lines look like this: y equal to a number. No x variable at all. So then all you have to do here, because it's horizontal, is, well, which one of these coordinates represents your y value? Of course, 1 does. So then our answer is simply y equal to 1. And it's that simple for this problem because it's a horizontal line. I do want to show you something. If you choose to do more work, I guess that's okay. If you did this, if you use the point slope form, you're going to get the same answer. You would plug in the y coordinate that they gave you. You would plug in 0 for the slope, and then you would plug in the x coordinate that they gave you right up here. You know, this x coordinate and that y coordinate. But guess what, guys? Once you simplify all of this, it's just going to lead you to y equal to 1. You know, because 0 times all of this will just be wiped out and just be 0, and then you add 1 to the right side. Okay, so I like to remember the following. This is what helps me. If you tell me that my line is horizontal, I know the equation looks like y equal to a number. I grab the coordinate that represents my y value, and I'm done. Find the equation for the line with undefined slope that's going through -3, 1. Okay, guys, undefined slope means that your line must be vertical because all vertical lines have undefined slope. Now wait a minute. If our line is a vertical line, then the equation looks like this: x equal to just a number. Hey, these arrows just mean implies, okay? If it's x equal to just a number, that's what the equation looks like. Well, which one of these numbers are you going to grab? You're going to grab the coordinate that represents x, -3. So then your equation is x equal to -3. Done, right? And it's done, it's that simple because you're talking about a vertical line. How did I know it was a vertical line? Because they said it's undefined slope. Check out this problem, it's pretty cool. Find the equation for the line that's going through -2, 5 and parallel to x equal to -3. For this problem, I am going to draw sketch a picture. For all of you that are visual learners out there, this is for you. Of course, you don't have to draw a picture, but I think it helps tremendously, okay? So here is my picture, okay? This will do. All right. Just bear with me. Bear with me. All right. I'm ready. Okay, so the first thing I'm going to do is I am going to sketch the graph of this line, x equal to -3. What does that look like? Well, that's a vertical line, so going right through -3, so this is what it looks like. Now, watch this. Actually, let me make that a little taller here so that I can drive home my point. Yeah, I think that'll be good there. Now, watch this. They said that you're looking for the equation of the line that's going through -2, 5. Where's -2, 5? I'll show you. -2, 5 is about right there, give or take. Your line goes through this point and is parallel to this vertical line. Wait a minute. Parallel means that you will never touch this line. If your line is parallel to this guy, that means your line and this line must never touch. So that must mean that your line has to go through this point and looks like this, is parallel, correct? Now, this line here is the line that you're trying to get the equation for, but it's a vertical line. So then that must mean your answer is just x equal to negative 2. That's your answer. X equal to negative 2. I'll box it over here. That's the equation of your line. Check out this one. Find the equation for the line that's going through 4, 1, and it's perpendicular to x equal to 2. All right, I'm going to do the same. I'm going to draw a picture, okay, everybody? So please bear with me. All right. Just give me a second. 1, 2, 3, 4. All right. They're telling you that you have this line here, x equal to 2. What kind of line is that? It's a vertical line going right through 2 on the x-axis. So a vertical line like that. Okay? Now, they're telling you that your line goes through 4, 1. Where's 4, 1 at? 4, 1 is right here. Okay? So your line goes through this point and is perpendicular to this line here. Lines that are perpendicular cross each other. But when they cross each other, they form a 90-degree angle. All right? So that must mean that your line looks like this. Like that, right? Making a 90-degree angle with this vertical line. In other words, if you are perpendicular to a vertical line, that just means you're horizontal. If this is a horizontal line, then that means that our equation looks like this. Y equal to a number. That's simple. But wait a minute. What number? Well, look at your ordered pair. Which one of these coordinates is your y coordinate? 1. So therefore, the answer is y equal to 1. This is the equation for this horizontal line. Any line that is perpendicular to a vertical line will be horizontal. All right, here's a summary that I think is really good for your notes. If you're parallel to a vertical line, then you have another vertical line. Okay? If you're perpendicular to a vertical line, then that must mean you're talking about a horizontal line. If you're parallel to a horizontal line, then you have another horizontal line. If you're perpendicular to a horizontal line, then you have a vertical line. So you may want to write those down, read those statements a few times, look at the previous examples so that you're making sense of this information. Okay guys, last example, and it'll be somewhat of an application. Derive the linear function that can be defined to convert temperature readings from Celsius as the x variable to Fahrenheit, f of x. Now what we know is that every linear equation can be written as a linear function with the exception of a vertical line. What this means is instead of writing y equals mx plus b, what I can do is write it using function notation. F of x is equal to mx plus b. This is not a linear equation per se, this is a linear function. Here, remember f of x, this notation just represents y. All right, so this is what they want us to derive, a linear function. Derive the linear function. So we have to derive a function that looks like this. Well, you and I are going to have to do some work in order to find two things. We need the slope of this linear function, basically the slope of this line, and we need the y-intercept of this line. So, in order to find the slope, we need 2 points. So recall that 2 points will always define a line. When you're talking about a line, you need 2 points to find the slope. So we're going to use these 2 points derived by comparing the freezing and boiling point of water for both Celsius and Fahrenheit, because that's what we're talking about in this problem. For Fahrenheit, freezing is 32 degrees, boiling is 212 degrees. Celsius, freezing is 0 degrees, and boiling is 100 degrees. Look at this problem. It says that Derive the linear function that can be defined to convert temperature readings from, watch this, Celsius, right here, as the x variable. So Celsius degrees represents your x value, and Fahrenheit represents f of x, or y. Remember, f of x just represents y. So then what I'm trying to get you to see is that this information here gives us a set of points. For freezing, you would have 0 degrees, right, comma, 32 degrees. Did you catch what I just did there? Here, let me, this is your x value and your y value. How do I know that? This is x, because Celsius is x, and Fahrenheit is f of x, or y, right? So those are this is your x coordinate for freezing. This is your y coordinate for freezing. The problem tells us that Celsius represents x, Fahrenheit represents y, or f of x. We have another ordered pair though. Here, I'll do it here. Another ordered pair, 100 degrees, comma, 212 degrees. What are these? Well, first of all, this is x, this is y. Here's x, Celsius for boiling, and this is y, or f of x, for Fahrenheit. Okay, so with these 2 points, you and I then can find the slope, right? All we have to do is subtract the y coordinates, so 212 minus 32, and then subtract the x coordinates, 100 minus 0. So let me move up a little bit. So then your slope for this linear function would be, let's see, 212 minus 32 is positive 180 over 100. And so I always tell my students kill the 0, so like that 0 for that one. And then just divide the numerator and denominator by the GCF, the greatest common factor, which is the largest number that divides into 18 and 10, which is 2. 18 divided by 2 is 9. 10 divided by 2 is 5. Okay, this is the slope. We needed it for our linear function. Now, the other thing you need for your linear function is your y-intercept. But remember that your y-intercept is the ordered pair where the x value is 0. But you can see it right here. X is 0. If x is 0, then this point is the y-intercept. So the y-intercept is 0, 32. For slope-intercept form, this value right there is going to be called your b value, 32. Okay, everybody, I think we have what we need. Let me move this up a little bit here. Okay, so what we have then is a linear function, so f of x, I'll write this down again, is equal to mx plus b, and we have everything we need. The slope is 9/5 times x plus 32. All right. Very good. Now, what did we just do? We derived a let me scroll back up for you. We derived a linear function that can be defined to convert temperatures from Celsius to Fahrenheit. Celsius to Fahrenheit. So what we just did is we found a function, a linear function, that takes you from Celsius to Fahrenheit. From Celsius to Fahrenheit. Now, to wrap this up, let's evaluate f of 25 and then interpret the results. Now, this notation, f of 25, is telling you to plug 25 in as your input. Let x be 25. Do you remember what x represents in the problem? Celsius degrees. So when you plug in 25 for x, you're plugging in 25 degrees Celsius. All right, let's do it. F of 25 will be equal to 9 over 5 times 25, and then plus 32. I don't know about you, but I always cross cancel. So then 5, if I can, 5 goes into 25 5 times, right? So then this is going to be equal to 9 times 5, which is 45, plus 32. So then this will be equal to 77. Okay, that's the evaluation. Now, let's interpret the results. So then this means 25, which was your x value, is your Celsius degrees, and 77 is degrees in Fahrenheit. In conclusion, 25 degrees Celsius is equivalent to 77 degrees Fahrenheit. Man, that was fun. All right, everybody, this concludes this lesson. I hope you learned a lot. I hope it was enlightening. I hope you had a good time. Take really good notes, and I'll catch you in the next lesson. See you later.